Hi, everyone. Thank you for joining our webcast. Today, we'll be discussing how you can find your dashboards faster and enhance reporting investments with AI. I'm Jay Pradhan, Principal Data and AI Consultant here at Thorogood. I have several years of experience in data and AI, and hopefully you will find the case we are sharing today useful. I've included my details on the screen here, so please feel free to reach out to me if you have any questions. I will reshare my details again at the end of the session. Looking at the objectives of today's session, we're going to start off with describing the challenge that enterprise organizations face in accessing insights that have been developed across various parts of any organization. We'll try and understand the business implications of this. After this, we are going to look at how we've leveraged artificial intelligence to help us address this challenge at scale for an organization. Following that, we're going to take you through a demonstration of the application we've described and talk you through how we've engineered the solution. Let's begin by breaking down what the challenge is and how it impacts organizations and their ability to access insights and drive business outcomes. Let us begin by looking at the problem that we are trying to solve. Many business users consistently ask questions about their company's data. For example, business analysts often need quick insights on things such as sales trends, consumer behavior, or churn rates. Executives want to see high-level KPIs and trends without having to wait for reports. Operations teams need up-to-date data on inventory, logistics, and suppliers. The issue we have is that reports that might help answer these questions are often hard to find and often contained within poorly governed reporting estates. Another consequence of this is that there is a heavy reliance on data analysts or engineers to respond to even simple queries. Business users trying to answer similar questions build on their own reports, and in doing so use non-standardized metrics definitions and don't always rely on curated data sets fit for purpose. Another consequence of this is users will often rely on someone periodically circulating manually extracted screenshots of existing enterprise reports in a report pack. As a result of this, ultimately decisions get delayed due to bottlenecks. Users get frustrated and produce ad hoc reporting using non-standardized metrics and datasets. Data teams feel overloaded with repetitive requests, and ultimately businesses miss out on potential opportunities. Given the challenge we have described, which I am certain a lot of you will have experienced within your organization, we will explore how we can leverage artificial intelligence to enhance the ability of users to answer questions. Before we jump into how we propose to solve the challenge we are looking at today, let's understand the universe of a reporting technology. For the purposes of today's webcast, we'll be showcasing how we've developed a solution that leverages AI to access reporting hosted within Power BI, but this can be applied to any reporting technology. So jumping into the different layers within the Power BI universe, we start with understanding what a tenant is. A tenant is the overall organizational container. Workspaces are collaborative spaces for teams within that tenant. The tenant defines high-level governance, while workspaces control access and collaboration for specific content. Reports, apps, and datasets are hosted within each workspace, which can act as a shared environment for teams or functions. Now, with that context, let's understand how we might look to address the challenge at hand today. If we break down our problem into its constituent parts, you will find that looking at the right report to answer a query a business user has can be broken down into two stages. First, understand the natural language query submitted by a user. So for example, sales of a particular product in a particular quarter, or understanding market share for a particular region for a category, or gathering information about a distributor's performance. Analysis of this query can be done by breaking it into meaningful components like metrics such as sales or market share, dimensions such as product or time, and semantics such as up to date that might be referenced within a question, or any such information supplied by the user that might provide additional context about the query. Second would be to map the user query against the characteristics of each report leveraging artificial intelligence. We do so by relying on report characteristics that can be gathered from the report and additional context that report owners might be able to supply to us. Through this approach, we can find the right insights without having to sort through dozens of reports while looking for answers to business questions. As we discussed, in order to develop a mechanism to match the characteristics of a user's questions and identify which report will best provide the information requested, we need to have gathered all of the different characteristics of a report. Doing this manually, as you can imagine, will be time consuming, as it would require each user to provide significant level of detail about each report within your reporting universe, and will make maintenance of this information cumbersome. This approach is therefore not scalable. Hence, we need to develop a mechanism of extracting the context from the report in an automated fashion. REST APIs are a mechanism that allow us to do that, to extract report metadata for any report that we might want to include within the scope of this tool in an automated fashion. And this thereby ensures that updates, new report launches, and additional reports from any different workspace can be included in our search each time we refresh the feed. APIs also contain other useful information, such as report names, filters, usage details. The technical design must ensure careful management of APIs given their limitations and permissions. Metadata information can, of course, offer specific information about a report. However, there's also an opportunity to enhance this context by leveraging user descriptions, tags, and any other contextual information that might enrich the context that we can leverage while searching for the most relevant report to a business query. This can be maintained using custom apps. As we've briefly discussed, we leverage large language models to extract and summarize metadata, and then synthetically generate a list of questions that each report can potentially answer, giving us a collection of questions that any user query can be matched against to find the most relevant report for any business question that a user might have. Now, given we've looked at how important it is that we are able to capture this information and gather as much contextual information as possible in a scalable manner, we should look at what signals will help us do this. REST APIs give us access to screenshots of each report within a workspace, and we can gather visual summary of the different characteristics of the report by passing the image to an AI image model and using that to describe the report. REST APIs can also help you access PBIX files, and their JSON scripts can be passed through a large language model to extract information such as types of visuals used in a report, details of the underlying data model, metrics used, and other such information. REST APIs can also help you access usage details, as we previously discussed, of any report. So you can understand which report is the most widely used for a particular query, which report is refreshed most recently and thereby contains the most up-to-date information, and all other characteristics that can play a role in improving the relevance of your search results. As we discussed in the last slide, users can provide critical context to enhance the detail we can capture about a report. So for example, passing contextual master data information, other useful tags, and other such information can further enhance the relevance of your search results. Before we jump into a demonstration of the solution today, I wanted to talk you through how our design focuses on ensuring we have a seamless experience in interacting with the tool as users look for reports that can help answer the queries they have. We've created a custom web app where the user will submit their question. In response to this, the tool will offer recommendations of relevant reports along with a score to rank the results. We've also developed a report action page that will have regular user queries which they might be interested in storing and revisiting periodically. Now, I hope you get a sense behind the thinking that went into our custom web app design and the emphasis we placed on making it easier for users to access the right report. Now, let me jump to the tool that we have developed and let me talk you through its features. As you can see on your screen, we've got a landing page that has provisions for any user to input their questions and to submit that request. So let's start off with our first question. What are the top drivers of profit change for retailers? Now that I've formulated my question, I can submit that. And as you can see, the tool recommends dashboards that could answer your question. I've got 3 results on the screen: retailer growth and performance with a relevant score of 95%, channel profitability and trends with a score of 83%, and retailer growth and performance again with a different view. All of these are contained within the Commercial Insights workspace. And I have used AI to create a description of each of these reports. I can then click on the one that it prompts me as the most relevant report. And as you can see, the report opens within the application itself. I can interact with the Power BI report just as I would in the Power BI interface itself and carry out any further analysis that I might want to. It also gives me the option to access other report pages if I might want to carry out additional analysis. I can then also navigate directly to Power BI from the window itself. And this opens up the window in the Power BI environment. So not only am I able to access the reports within the application, I'm also able to navigate to Power BI to carry out any analysis or any changes I might want to. Let's look at another query. How does actual retailer profit compare to target profit? As you can see, I have a different result now. And this result has a 92% accuracy or confidence score. Again, this is from the Commercial Insights workspace. And I've got a description of what this report has. Again, navigating to this page brings up the relevant report, and I can carry out similar analysis as we previously looked at. I can also favorite this report, as you can see I have done here, and this will be available within my favorites tab. Through this, you can actually capture some of the questions that you have regularly and the analysis that you might want to run regularly. So rather than having to search for that every time, you can favorite this question and the result that has come up and the dashboard that you've used to answer this question and access this through the favorites page. It was important for us to also create an ability for users to add new reports to this. And one of the mechanisms to do that was to provide access for the application through a service account to the workspace itself. So hence we've provided specific details on how you could do this. And once you've added the service account as and given admin privileges to it, to the workspace, you can find your workspace comes up here. You can then include this within the scope of the tool. And all of the reports that are included within the workspace will be included within the scope of the tool once the feed refreshes. We also have other features because with the application of artificial intelligence to different data sets, we'd like to think of this application as a universe which you can use to access different data sets. So you've got the ability to search text, you've got the ability to search different data sets within the same platform. But we'll look at this in perhaps a follow-on session. So now let's go back to our presentation and look at how we've solved the challenge and how we've engineered the solution and explore its constituent parts. Let's start by discussing how we leverage the data platform to connect to the reporting tool and build the relevant information that can help answer any user query that is submitted. Reports that we want to consider for the scope of the tool are hosted within different workspaces. We leverage the data platform to connect to the REST APIs with the help of Databricks and extract dashboard screen grabs, Power BI layouts, and other information we have discussed previously. We also ingest contextual information through the web app, and we have hosted this using the Azure App Service, and we structure all of this information using Databricks. This information is then passed to a large language model, which we prompt to come up with all of the possible questions that any report can be used to answer. This approach allows us to leverage artificial intelligence to use the information we've collected to describe the use cases the reports might be able to respond to. These AI-generated questions are then transformed into embeddings, which we can search against any input query we receive from the user and identify the best corresponding report. Having built the data perspective, let's discuss how we engineer the mechanism that maps any input query shared by the user to the most relevant report. The web application we've developed allows the user to submit a business question. The web app API then passes the search phrase to the backend, where we have an orchestration framework that calls Azure AI Search Service, which we use to break down the user query into its constituent parts, and then use that to match it against the question embeddings that we had created previously for all of the reports across the Power BI tenant. Upon finding a set of relevant reports that match closely to the user query submitted, we then rank the results using a large language model and subsequently extract the relevant information associated with the report to help us surface the report within the web application. We use details such as dashboard name, dashboard URL, report area, report details, as you saw previously in the demonstration. This information is then passed to the web application through which it is surfaced to the user. So just to review what we've discussed, as we build the data perspective, we use Power BI REST APIs to connect all of the information we need for each report. And we use large language models to describe the questions that any report can help answer. We use Azure AI Search, both to convert the questions that the large language model has come up with into searchable embeddings, and then also to match those with the user query that is submitted. And then finally, we use a custom web application as an interface for the user to submit their queries. and interact with the results that the solution delivers. I hope the solution, as we described, is able to answer some of the questions you've been having around how users can access the right insights faster. I'm conscious that some of you will not have engaged with us previously and might not know who we are. So let me share some information about who we are and how we can help you. Thorogood is an independent global professional services firm specializing in data engineering, data visualization, strategies, solutions, and services with a focus on our customers. We are a global company with offices in Boston, Philadelphia, London, Bangalore, Singapore, Paolo. Our consultants are recruited and trained in the same way to develop a unique mix of skills, blending business understanding in the form of industry and functional experience with strong technical aptitude and a deep understanding of analytical tools and techniques. We offer a full range of services across the spectrum in which we operate in, including strategy and roadmaps, requirements, design, implementation, and training and support. We deliver solutions for some of the world's leading enterprise organizations. Typically, we work in data-rich verticals, mostly in consumer packaged goods, pharmaceuticals, banking, and insurance, though we have experience beyond these sectors as well. We take pride in the broad and long-standing relationships we've cultivated with customers over the years, and the nature of the work we do varies greatly depending on the business needs of our customers. Thorogood is an independent consulting firm. Our independence allows us to provide an unbiased perspective to our customers on technologies. We have deep expertise in Microsoft Azure, AWS, GCP, Databricks, and others, allowing us to leverage the best technologies for our customers' unique needs. Leveraging AI to recommend reports can be a very powerful and impactful tool, but as highlighted, there are many potential considerations in development stages to navigate. Here at Thorogood, we help provide those expertise to maximize the results for our customers. So thank you for joining today. If you'd like to know more, please do not hesitate to reach out to us. Our website and YouTube pages are also filled with content and use cases we have been gathering throughout the years, and I'm sure you will find something useful for you. We hope you enjoyed and learned something from today's webcast, and we hope to see you again soon. Thank you.